So now, dear student, let us talk about electroplating process in very in-depth detail on the basis of a chemical reaction which may take place inside the electroplating solution or on the surface of the plates which are used in electroplating cell. We will talk about the chemical oxidation reaction. We will talk about a reduction reaction. We will talk about the anode and cathodes, or the role of the plates which are used in electroplating solution as a cathode and anode. So in case of a deposition of a silver atom on the surface of a silver ion on the surface of the copper atoms using electroplating process, we need to convert a silver atom into a silver ion. This conversion of a silver atom into a silver ion is done when a silver plate is connected with a positive terminal of the potential source. Positive terminal of the potential source basically attract the electron from the silver atoms. So when an electron is attracted or when electron is taken away from the silver atom by the positive terminal of the potential source, the silver atom, which is in a neutral form and it is a part of a silver plate, it will be converted into silver plus 1 ion like this. An electron is given by a silver atom will get converted into a silver ion, and in case many of the silver atom, if they give an electrons, then many of the silver atom will be converted into silver ions. So in case of copper metal side, a copper metal is connected with a negative terminal of the potential source. So negative terminal potential source basically they basically push away the electron from their negative terminal toward the copper metal like this. So electrons are negatively charged, whereas the silver ion are positively charged. So both of those particles, they are oppositely charged, so they will attract each other. So when the electron and silver plus ion attract each other, then the silver plus ion, by gaining electron, will be converted into neutral silver atom like this. These neutral silver atoms, which are converted by gain of electron by silver ion, they cannot be longer part of the electroplating solution because they are not dissolvable. So these neutral atoms will move toward the surface of copper metal and they will be deposited onto the surface of copper metal as a thin films. So this is how we can represent an electroplating process by a schematic diagram. Now, dear student, let us explain the electroplating process using a chemical equation. As you know that in electroplating process there are two types of chemical reactions take place. One type of chemical reaction is known as an oxidation reaction. Oxidation is a reaction in which an electron is lost by an atom during a chemical reaction. So electron is basically lost by a silver atom at the silver plate. So oxidation will happen at the silver plate side, whereas a reduction is a gain of an electron during a chemical reaction. So reduction basically happen at the copper plate side of the electroplating solution. So we will write a chemical equation for both reduction and as well as oxidation reaction. Student, let us start or let us write the chemical equation for a reduction reaction that is happened at the copper side of the electroplating cell. As you know that we start with a silver ions. These are the silver ions which are present in a solution. So silver ions are the part of the solution. So if we want to write a reduction reaction, then we will have a silver plus ions which are the part of an aqueous solution. So this state is they are in the liquid state. So in parenthesis after the silver plus we will write an aqueous for aqueous. Since silver ions are gaining electron, then we will write plus electron and then an arrow after that. So silver ion have gained an electron and will give us a neutral atom, and which will be a result of a gaining of electron, and on the opposite side of the arrow we will write a neutral silver atom. Neutral silver atom is in a form of a solid phase. So in parenthesis we will write S for a solid. So this is an equation for reduction reaction. As I have previously discussed, reduction is a gain of an electron. So electron is gained by a silver ion which is in the aqueous form, and when the electron is gained, the silver ion is converted into a solid silver atom, and in this form we write a reduction reaction in electroplating of a silver atom on the surface of a copper plate. Now we are going to write the oxidation reaction which take place at a silver plate side. The student, please note that the oxidation reaction is little bit trickier. So on the piece of a silver we start with a neutral silver atom. So what is a physical condition of these neutral silver atom? The physical state of the neutral silver atom is that they are part of a solid. So we will write silver atom and in parenthesis we will write S for solid. Now silver atom is losing electrons, so I can write minus E. The student, please note that this is for explanation. It is not a correct equation, but I will fix it in just a minute. So by losing an electron, a silver atom will become a silver ion, and which will be written after the arrow of an equation. So we write silver ion and it is dissolved in a solution. So the state of the silver ion is in aqueous. So we will write AQ with after the silver ions. So now, what do you think? What is wrong with this equation? What is wrong with this oxidation equation? The minus sign is wrong, because in the chemical reaction you cannot subtract anything, but you can just add the things. So you cannot put minus sign in front of these electrons. So then how can I show that the silver atom, which is in a form of a solid phase and it is a neutral, and how I can show that this neutral silver atom is losing electron without representing minus sign. So what we will do, we will move this minus electron to the other side of the chemical equation. So the negative sign present before the electron on the other side will change into a positive electron, and so we will rewrite our equation as like this: silver in as a form of a solid, and then we'll put an arrow, and then a silver which is in a form of aqueous, and it is a silver ion, and now an electron on the other side. I will change its sign from minus to plus electron. So this is a correct way for writing an equation for the oxidation process. So these are the two equations telling us, these two equations are basically telling us what is going inside the chemical or electroplating cell. Now, if you look at the diagram and also look at these two equations, you can definitely tell there is clearly a transfer of electron taking place. So there is definitely an oxidation and reduction process on the surface of the electroplating plates and as well as inside the electroplating solution. So now I'm going to discuss what is going inside the solution of electroplating cell and at the surface of electroplating plate in terms of oxidation reduction reactions. As you know that reduction is in chemistry is a chemical reaction. In a chemical reaction, if an atom gain electrons, then there will happen a reduction reaction. Whereas in case of oxidation, an electron is lost. Okay, so now let us discuss what is going at silver plate site. We have neutral silver atoms. They are losing electron because the silver plate is connected with a positive terminal of the potential source. So the potential source, basically a positive terminal of potential source, pull the electron toward itself. So due to this, a silver atom loses its electrons and it is converted into silver plus ion. So the loss of electron is oxidation reaction. So this means that an oxidation reaction takes place at silver plate side of the electroplating cell. On the other hand, on the copper plate side, silver ions, these ions are basically gaining electron. So reduction is a gain of electron. So reduction will happen at copper plate side. So this means that oxidation is happening. The oxidation reduction process is happening inside the electroplating cell, whereas on the surface of the silver atoms, the silver atoms are losing electrons, so oxidation reaction will happen at the surface of silver atom. They get converted into ion and they become a part of the electroplating solution. Whereas on the side of the copper plate, here silver ions are gaining electron. So the gain of electron is a reduction reaction. So reduction reaction will happen on the copper plate side of the electroplating cells. Now both the oxidation reaction and reduction reactions are known as are known as half reactions. Why they are known as half reaction? Because each oxidation reaction and reduction reaction basically tell us half of the story of the oxidation reduction process. So based on oxidation reduction happening in these electroplating devices, we can give name to the part of the electroplating device. So we basically give name to the part of electroplating cell is a cathode and anode. The site of oxidation is known as anode. Whereas the site of reduction is known as cathode. So in electroplating of silver on the surface of a copper metal plate, the silver side acts as an anode, and whereas the copper side acts as a cathode. So now, dear student, let us conclude electroplating process. Electroplating process is a process in which one of the metal is transported in a very small amount on the surface of another metal in a form of a thin film. The transfer of the metal in a form of thin film onto the surface of another metal take place in electroplating cell, which is based on the metals, the two metals which we are going to use for electroplating, and these metals are connected with potential source. So potential source, the role of the potential source is very important. Potential source pull the electron and as well as they push the electron between the two metal plates. In order to make an electroplating successful, both the metal plates like the silver plate and as well as copper metal plate are placed in a solution. A solution is made up of an ionic compound and they are known as electrolyte. These ionic compounds are usually dissolved in a solution, and the role of the ionic compound is very important. They allow the current to pass through the solution. So in this way, a circuit is basically completed in an electroplating cell, and after completion of a circuit, the transformation of a neutral atom onto the surface of another metal become possible, and deposition will take place in the form of thin film on the surface of other metal plate. So dear student, this is all about electroplating process. So this lecture, I have simply explained the electroplating process. However, if you want to know in-depth information about the electroplating process, you can follow our comprehensive lecture on electroplating process. So, dear student, thank you for watching this lecture.